Hello guys, today and in the upcoming videos we will protect our tunnel with something more solid than a simple XOR. Now modern malware are using a well-known encryption algorithm to protect its traffic. In this lecture we are supposed to do a quick refresh on cryptography basics. So if you are already familiar with the cryptography, please feel free to skip this lecture. Now to begin with, there are two types of encryption algorithms. We have symmetric and asymmetric encryption. And this classification is made based on the number of the needed keys and how they are operate. In symmetric encryption, we use one key to do both the encryption as well as the decryption operation, and the same key must be shared on both the client as well as on the server side. Now, the most algorithm that is used for symmetric, it's called AES. And in the next lecture, we will use AES to encrypt the tunnel between the target and the attacker machine. Now, the steps for doing so, first of all, we need to generate the symmetric key. And this key, as I said, must be shared between both sides. So it must be shared on the Kali side as well as on the target side, similar to what we did with the XOR. Then we need to create a function that before passing any data, we need to pass the data in a clear text to this function, get the encrypted data, and then send it to the remote target. And the reverse logic is going to happen once we get any data. First of all, we need to decrypt this data, get it back to clear text, and then process that data. Okay, the second type is asymmetric. In asymmetric, we have a concept of key pair where we have a key that is called public key, and that public key is used for encryption, and we have the private key, and that private key is used for decryption. Now the key name implies that the public key can be published over the internet, and doing so will cause no damage because this key is only used for encryption. It can only encrypt the data. On the other hand, the private key should never leave the operating system or the machine, and if this private key has been leaked out of the operating system, then anybody who has that private key can decrypt the traffic. So we will use the asymmetric encryption in our scenario as the following. The target has to generate its own key pair, and also the attacker has to generate its own key pair. Now, after generating the key pair on each side, the operation is going to be the following. The target is going to hold its own private key, but it will also hold the attacker's public key. And on the other side, the attacker will hold its own private key, and it will also hold the target public key. So before sending any command on the attacker machine, let's say this is the command that we want to send. And let's say, for example, it is ipconfig. So before sending any command to the target, the attacker machine is going to use the target public key to encrypt this message, and then we send it over the internet. Now, no matter who's watching this traffic will not be able to decrypt because only the target has the private key which is used to decrypt the traffic. So when the target gets this encrypted message, and let me just type this encrypted message, it's going to use its private key to decrypt this message and get back the clear text command. And in this case, it was ipconfig, for example. And at this point, the target is supposed to execute this command and send back the result. Let me just go with a different color, and I will go for green. So this is, for example, the output of the command execution. The target is going to use the attacker public key to encrypt this message. So at this point, we would have the encrypted message sent over the internet. And again, no matter who's watching this message, he will not be able to decrypt it because only the attacker has the private key to do so. So once this message reached to the attacker machine, the attacker is going to use its private key to decrypt this message and finally print out the command execution output for ipconfig. The asymmetric is considered more solid and more secure than the symmetric. However, it requires more processes and much slower than the symmetric. So in real world, protocols like SSL use a hybrid technique as following. The asymmetric algorithm is only used to securely transfer a session key, which this session key will be used later on to encrypt the actual data using symmetric algorithm. So the asymmetric is only used at the beginning of the session to securely transfer this session key, and further communications are protected using symmetric encryption algorithm. Okay, so to reflect that in our scenario, we can use the hybrid technique as following. The attacker is gonna hold the target public key, and also the attacker is gonna generate a session key. So let's say this is session key, but in order to securely transfer the session key to the target, we're gonna encrypt this session key using the target public key. So here we're gonna have this encrypted message, and we will send this encrypted message to the target. The target is going to use its private key to get back the clear text version of that session key. So let's say this is our session key. Now at this point, both the attacker and the target have this session key. And then this session key is going to be used as symmetric encryption to protect our tunnel afterwards. Okay, so one of the advantages beside the CPU processing in the hybrid technique, that this session key is randomly generated and it will be changing on each connection. So instead of hard coding the session key on both sides, this session key can be generated and it will be random per each connection. Moreover, you can update the code and enhance the key derivation using Diffie-Hellman algorithm on your own. In the upcoming videos, we will code these three discussed methods, which again, the symmetric, asymmetric, and the hybrid. I hope that this lecture has been informative for you, and thanks for watching.